Okay, so what we have here is, hold on one second. I got some students. Okay, let me try this again. I think it's going. Okay, so the way you do these is you have your force diagram will be like this. So me make a dot, right? And this thing is being pulled at an angle, and we're going to call that FA. You could call it FA or FT. What's that called over there? It doesn't really say, but it could be either FA or FT. And it says the mass is 140 kilograms, and it says that the pulled at an angle of 30 newtons, and it's at angle. This angle here is 22 degrees. So this is different than one of the ones that's on a slope. This is different than one of those on a slope. The direction it's moving is this way, and so we want to make our x the direction it's moving. So that'll be our x axis, and so then our y axis will be this way. I'm going to actually move this down a little bit so you can see a little bit more on the top there, and I can scroll down to it. Okay, so anyways, so our normal force actually will be coming up here somewhere. That will be our normal force up here somewhere, Fn. And of course we have Fg. Now Fg is always going to be just mg. I mean, because it's the weight of something. So Fg is equal to mg. But the Fn actually is the force that's on the scale, right? So if I'm sitting on a bathroom scale, if I'm standing on a bathroom scale, and I'm sitting here and I'm reading it, right? It says, okay, it says however many pounds. If I push down harder, maybe you push down my shoulder or something, it's going to read higher. This actually is Fn. But if I lift up, it's going to change. And so what I'm trying to tell you is that Fn actually can change, but Fg can't. Right, so Fg is going to be mg. Fn can actually change, and so I'll show you how Fn changes. So in this case, since the person is pulling at an angle, they're actually pulling over and up at the same time, and so it fits right inside here. Right, so this is Fa. Like I said, you could call it Ft, you could call it Fa. Either one doesn't really matter. And then this one here we would call Fa in the y direction. In this one, we would call Fa in the x direction, and we're breaking it up into what are called components. And this is an easy one because this is 22 degrees. It's shown right there. Now, the object says that it's a rough surface, and a rough surface means it's going to have some friction. And I think it's being pulled. Constant velocity. So constant velocity means v equals constant. It means if constant velocity, that means a equals 0. That's pretty important. If a equals 0, then our net force has to be 0, which means all of these have to cancel, all our ups and downs. So if our net force must be equal to 0, then all of these arrows have to somehow cancel, right? So if I look at this, these are all the arrows I actually have. That means that this FAX, this sideways FAX, has to be the same size as this FK. I'm going to actually make it the same size. So I'm going to erase this. I'm going to erase this. I'm going to make that the same size. And so this thing here will be the same as that. And this is my FK, kinetic friction, because I'm moving. But I know they're the same because it's moving constant. There's no there's no unbalanced force, okay? And so that means that the sum of the forces the sum of the forces in the x direction are going to be 0, right? And so that means that Fk will be equal to Fax. You just got to remember that Fax is to the right and it will be positive, and Fk will be to the left and that'll be negative. So how do you get Fax is using SOHCAHTOA. So in SOHCAHTOA for Fax, so Fax for SOHCAHTOA is going to be equal to FA, which is the hypotenuse. So let's look at we got hypotenuse and we got adjacent. So we're using cosine. So FA cosine theta. And so what I mean by that is if we have this is 30 and this is 22, and then we use cosine theta equals ka, which is adjacent, right? We say ka, right? Cosine theta equals adjacent over hypotenuse. And so cosine theta, and we're trying to find the adjacent. So what we do is you times the hypotenuse on both sides. And so you get hypotenuse adjacent is equal to hypotenuse times cosine theta. So this is adjacent is equal to hypotenuse times cosine theta. That's where I got that information right there. And so FAX is going to be equal to 30 times cosine of 22, and FAX will be equal to FK in this case. Remember, FAX is going to be positive and FK is going to be negative, but they'll be the same. Okay, it's a little harder to get FA, harder to get FAY in the normal force. And let me show you why that is true. So, okay, so with FAY and the normal force, these two things, they both equal FG. So it would be Fn. So the sum of the forces in the y direction also has to equal 0. The sum of the forces in the x direction equals 0. The sum of forces in the y direction equals 0. That means Fn plus Fay equals Fg, right? So then I would say, okay, if I want to know Fn, and I think this one is what we're looking for, horizontal component of the applied force, vertical component of the applied force, frictional force in the wagon, weight of the wagon, force of the surface. Okay, so it looks like you only got right so far is the weight. So this one is this weight is, you said it was 1372, and that's down, so it's negative, right? So okay, so negative 1372, and so Fn plus Fay, and so Fn is going to be this thing. And then Fay is the vertical component. Fax is the horizontal component, right? So the vertical component, Fay, is going to be equal to the sine of 22. So it will be Fa times the sine of, not 32, but of 22, Fa sine theta. Just to show you a little bit easier to see it, I guess. That's the vertical component right there. Right there. Fa is Fa sine theta. So we have Fn is what I want to know. So basically what I'm going to have is I'm going to have Fn plus Fa sine theta, which will give me Fay equals a negative 132. And so then if I do this, I have Fn equals, and actually this is, we should look at this as a positive in this way. Another way to look at that, so sometimes the signs are hard, but another way to look at that is to, we look at it this way. We say they don't actually equal, technically speaking, minus Fg will give you 0, or plus Fg will give you 0. What I mean by that is if this is a minus 1372, because that's a negative, or plus a negative 1372 equals 0. There's an easier way to show you this, but I'll show you that in a second. So let me just do this one for you. Fa, just show you have real numbers on that so it makes sense. So if I do 30 times 22 sine my horizontal component becomes 11.24 rounded off. So I basically get this Fn plus 11.24 plus a negative 1372 equals 0. And so if I get this and I put this on the other side, I'm going to get should equal, oh, what am I doing? 1372 minus 11.24 equals 1360.76. Okay. Now, a lot of people go like, okay, this might be a mess of stuff to look at. So how can I make sense of that? Well, the way I'm going to make sense of that is I'm going to show you something. I'm going to get rid of most of this stuff. I'm actually going to get rid of a lot of this. Get rid of that even. Okay. And we don't even care about FK in this case. All we're looking at here is the vertical, right? So what we're saying is that the sum of the vertical forces, or the sum of the force in the y direction, have to be 0, which means this plus this have to cancel out. And you told me that this one was, I'm just going to move that over so you can see it better. I'm going to say this one, and this is the best way to look at it really, is a negative 1372 newtons. You said that FG was down 1372. So the question is, did I do my math here right? Well, if I look at this one, Fn, and I call Fn 1360.76. So that one is 1360.76. And what is FAY? FAY is the other up one. So I have my two up ones, and I have my one down one. And if you say FAY is equal to 11.24, then hopefully you can see that if you have these two, this one and this one, and you add them together, right? This plus this one, you add them, you're going to get that. And so that's saying that these two aren't the same. They're, basically something different. And this is not the same either, right? But this and this are the same as that. So anyways, that actually answers all your questions. The force the surface applies is this one. Now, if you really want to understand how to do this, I would do it again. The force that is the vertical component of it, of the force, is that one. The force that's the horizontal component is that one, which is FAX. And then FK is the force that the friction applies, is that one. And I've covered all of them, but a little bit messy. But anyways, see if that makes sense to you. I would definitely do that quiz question again with different numbers to see if you can solve it on your own. All right, anyways, let me know if you need more help.